All right, good afternoon, students. This is Mr. Kutsi, and I'm going to be sort of going through how to solve the problems from 5.6 and talking about what the heck a rational zero is, what it means to us. Okay, so basically what we're going to do for an example is go through number 12 from page 374. What you see here is a polynomial function, okay? And what our goal is, I'd like to sort of establish what our goal is. Eventually, we're going to try and graph this, but our goal for right now is to eventually get this so it's three separate factors. Now, there's a couple things we need to point out here. I know it's three separate factors because of the power of 3 up there. Yeah, let me use a different highlighter. Power of 3 up there, three separate factors. That's what we got. I made this a little bit messy, but that's the power of 3. So, how do we get from there to there? That's the thing. That's the whole goal of this section of the chapter. So what it is the method we used. We can use long division, we can use short division, or actually it's called synthetic division. And we're going to use synthetic because it is shorter than long division. Okay. So I'm setting up the synthetic division. Here we go. Now, the rule for synthetic division, we're going to put the number we're going to try up here, okay? But what do we try? Where do we start from? And that's where we need what's called the rational zero theorem. What it says is if you look at 56, and this makes sense, 56 is going to come out of these three factors. So the only way you're going to get 56, whatever numbers work, must be numbers that work as factors of 56. So those are what we call the possible zeros. And they're any number that divides into 56. So like 1 divides into 56. 2 divides into 56. 3 does not go into 56. 4 does. 8 does. 7 does. Whoops, I missed 7. Okay. So we want to list all of them. Okay. Dot, dot, dot. I mean, up to 56 itself. As many factors as you can find. The other thing is they could be positive or negative. Okay. I'm going to put a little cloud around that. All possible factors. I didn't list all of them, but anything that divides into 56. Okay. Here's the guess and check part. We don't know which one's going to work. So let's start with the smallest one. Let's start with 1. Synthetic division. Bring down the first term. After that, it's multiply. Write the answer. Add them together. -4. Multiply. Write it up here. Add them together. -26. Multiply. Write it up here. Add them together. This would be our remainder. That's no good. That's not what we want. We don't want zero. We want zero remainder. We don't want to have a remainder. So we got to try this again. Okay, so ordinarily what I would suggest is erase this middle line here and this bottom line here. I don't have an eraser because I'm writing a pen, so let's cover it up. Again, like I said, we're going to have to do guess and check a couple times. It's the only downside to this. So 1, -5, -22, 56. But how I would view it is practice. It's going to make you get faster. In the long run, you're going to be a better calculus student because of this. All right. We could try -1 and see how that goes. But if 1 didn't work, I'm not too hopeful for -1. We could try 4. We could try -4. Let's try 2. Let's try -2, in fact. 1, -2, so we multiply, write the answer up there, add them, -7. Multiply, -14. Oh, no, sorry, +14. No, that's not going to work. All right. So that didn't get us there either. Okay. We've tried 2 now. It doesn't work so far. That's okay. We just try one more time. We're going to hit 1 eventually. There's 3 numbers that work. There's only a limited possibility. We're just not getting lucky yet. So erase that. Start over again. 1, -5, -22, and 56. So -2 did not work. Okay. Let's try, let's see, 2. 2 did not work. That doesn't mean -2 won't work. So -2, we're going to try it. Bring down the first term, 1. -2, -7. Huh. Oh, wait, I'm sorry. Shoot. We already tried -2. We needed to try +2. Let's fix this. If that was a +2, this would be a +2. This would be a -3. There we go. Okay. 2 times -3 gives us -6. These together gives us -28. Multiply that, that gives us negative 56, and we get 0 remainder. That's what we wanted. That's it. That's exactly it. 0 remainder is good. What we're interested in is the rest of this. What this represents is negative 28. Moving up, this is 3x. Moving up, that's 1x squared. What about this 2 over here? That's a factor. Okay, even though it's plus 2, the factor is actually x minus 2. As you should remember from long division and synthetic division, how synthetic division flips it to the opposite and everything's addition. If that's confusing for you, go back and review synthetic division and say, oh yeah, okay, it's always like that. That will always be the case. Okay, now we're not done yet. We're almost there. We're so close. Bring down this x minus 2. That's one of our factors. We can't break it down more. But this we can factor down. Negative 28 and then negative 3. To get x squared, we're going to have x times x. How are we going to get negative 28? Well, that could be 14 times negative 2, but that doesn't give us negative 3 in the middle. If we tried negative 4 and 7, that's good, but that would give us a positive 3 in the middle. So if we try a positive 4 and a negative 7, they multiply to make negative 28. They add up to negative 3. That's it. That's our factorization. So our positive 4 and negative 7. If you FOIL this out, it would give you this. If you distribute this all out, it would give you that. Okay, well, let's keep that there. And again, the magic here is you've taken this and you've done cosmetic surgery on it. It's still the same function, but we've written in a totally new form. That's important because this will be the next step in graphing. So please try to finish up page 374. Hopefully it makes much more sense. If not, bring lots of questions tomorrow and we'll talk about them as much as we can. All right, have a great afternoon. And thanks for watching.